Hello everyone, welcome back. Today we are going to do class 9th, chapter 2nd, motion in one dimension. It's third exercise, numerical problems which are unsolved given in the exercise. So before starting the numericals of exercise, let's revise some of the important formulas, equations which we need to use while solving the numericals. So the first is, these are the equations of the uniformly accelerated motions which are moving in the one dimension. So first is v is equals to u plus at, where v is the final velocity of a moving object, u is the initial velocity, and a is the acceleration of the body or moving object, t is the time. Next is s is equals to ut plus half at square, or you can write like this also. This is the most useful. S is equals to ut plus half at square, where s is the distance here, u is the initial velocity again, t is the time period, 1 by 2 constant, a is the acceleration, t is the time again. Next is third one, v square is equals to u square plus 2as. V square is this is the final velocity, initial velocity, acceleration and the distance. These are the three equations which you have to learn as it is along with the sign. You can see here all the equations are written like every sign is the positive only. So two formulas are related to the v. One is with s is equals to ut plus half at square. Remind it as it is along with the sign. The next is, these we have done in the first exercise also. That is, acceleration is equals to change in the velocity divided by the time. Change in velocity is final minus initial. Average speed is total distance traveled divided by the total time taken. Average velocity we can find as the sum of the two velocities which are given in the question divided by the 2, which gives us the average value for the velocity. So let's begin with the first question. So the first numerical is, a body starts from rest with the uniform acceleration of 2 meter per second square. Find the distance covered by the body in 2 seconds. Firstly, we are going to write what are the things given in the numerical. A body starts from the rest. Starts from the rest means initial velocity is 0 here. And with the uniform acceleration of this means acceleration is given 2 meter per second square. Find the distance covered by the body. S is equals to question mark in 2 seconds. Time is also given, that is 2 seconds here. So write firstly what are the things which are given in the numerical. These are the given things and what we need to find out. Now check here which equation is appropriate to use in the numerical. You can see here S, U, A and T. These are the things. So it means we can simply use a second equation for solving this numerical. What is the equation of uniform accelerated motion here? S is equals to ut plus half at square. This is the equation. S we need to find out. So write it as it is. U is the initial velocity is 0. Time is 2 plus half. A is 2 and time is again 2. You can see the units are also in second. No need to change any of the unit here. All are in the SI. So S is equals to, this becomes 0 plus AT square. So square must be put here. Half is cancelled on with the 2. 2 2s are 4. So S is equals to 4 meter. This is the answer for the given question. Second numerical. The second is, a body starts with an initial velocity of 10 meter per second and the acceleration is 5 meter per second square. Find the distance covered by it in the 5 seconds. Firstly, what are the things given to us? Initial velocity is given. It is 10 meter per second. Acceleration is 5 meter per second square. Distance covered we need to find out and the time is given in the 5 seconds. So these are the things which are given already. Same, this question is matching with the first part. Yes. So we can simply use the same equation in the second also. S is equals to u into t plus half into a into t square, which is 50 plus 5 5s are 25, 25 5s are 125 divided by 2. You need to take LCM here. After taking LCM, this is the value which I am getting, and this is equals to 112.5 meter. So S is equals to 112.5 meter for the second numerical. This is your answer. Let's do the third one now. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. After 2 seconds, it is 33.6 km per hour, means velocity increased. And after further again 2 seconds, it is 37.2 km per hour. Again velocity increased, means the motion is the accelerated motion because the velocity is changing, and change in velocity is known as the accelerated motion. The next is, now see here, up to this we are given with the 3 velocities between the 2 time periods. Find the acceleration of the vehicle in meter per second square. Is the acceleration uniform? This we need to find out. Okay, so here what are the things given? Starting velocity is given. Just assume it the first velocity. This is the first velocity which is given 30 km per hour. Then second velocity is given 33.6 km per hour, and the next velocity is also given 37.2 km per hour. The time difference for this is 2 seconds, and the time difference for this is also 2 seconds. We need to find the acceleration in the meter per second scale, this value, and we have to tell that the acceleration is uniform or not. So let's start with the first case. 2 cases will become here. How? Because by using these 3 velocities, we will have the 2 cases. The first case is like change in velocity is the acceleration. So A is equals to V minus U by T. In this, we will use the first V1 and V2 velocity. Then V2 velocity is the final velocity. So this is the 33.6 km per hour minus 30 km per hour divided by the 2 seconds, because time is 2 seconds. So because these two are in the kilometer per hour and we need to give the answer in the meter per second square. What is the conversion for it? We know that 1 kilometer per hour is equals to 5 by 18 meter per second inverse. So these two will change into the meter per second inverse, and the acceleration will come in the meter per second square. How? Because this is also in the second, so 1 square we will get from this, right? So because of this, we are multiplying this given value with the 5 by 18 also to convert into the meter per second. That's why. Now let's solve this. After solving these two values, we are getting 3.6 divided by 2 multiplied by 5 by 18. This thing now you need to solve. We can just replace the decimal with the 0. What are the things we are getting? Like 18 2s are 36, 2 10s are 20, 5 by 10 it is 1 by 2 again. So we are left with 1 by 2, which is 0.5 meter per second square. This is the value of acceleration from the first case. So it means A is equals to 0.5 meter per second square. Now for the second case, same formula we will use. A is equals to V minus U by T. Here the final velocity is this second one, V3, that is 37.2 minus 33.6 divided by 2 again. And to convert it into meter per second, we are multiplying it with 5 by 18. After getting subtraction of these two, we are getting 3.6 into 5 by 18. You can see this is same as the above equation, that is 36 by 20 into 5 by 18. 18 2s are, and this we are we got 1 by 2 meter per second square, which is 0.5 meter per second square. It means acceleration is again 0.5 meter per second square. You can see the acceleration in both the cases is same. It means what is the value of acceleration that we need to find out is 0.5 meter per second square. Here also 0.5 meter per second square. So this is the value of acceleration, and the acceleration is uniform. Yes, the acceleration is uniform because the acceleration is changing with respect to the time, with respect to the same interval of the time. It is changing uniformly in the continuous manner means. Now numerical number 4. Next is a body initially at rest. Now we are writing the things which are given to us side by side. A body is initially at the rest means the initial velocity is 0 meter per second because it is the velocity, so it means per second we are taking, not per second square. Starts moving with a constant acceleration. Acceleration is given 2 meter per second square. What we need to calculate? The velocity required means the final velocity we need to calculate, and the distance traveled. Distance traveled also in 5 seconds. Time is given 5 seconds. Two things we need to find out here. The first is this one and the second is this one. For finding the first thing, we can use the simple equation of motion. V is equals to u plus at. This is the equation of motion. So V we need to find out. U is the 0 here. A is given 2 and time is given 5. So V is equals to 5 to the 10 meter per second. This is the initial velocity of the given body. This is the first part. Then the second, displacement or the distance we need to find out here. Distance is S is equals to ut plus half at square. S is equals to u is 0, t is 5 plus half the value of a and the value of t square. S is equals to 0 plus 2 will be cancelled out with this. 5 5s are 25. So S is equals to 25 meter. This is the value of distance travelled in 5 seconds for the question. So fourth question is also completed. Come to the fifth now. Question number 5 is a bullet initially moving with the velocity 20 meter per second. Initial velocity is given, means u is given 20 meter per second of a bullet, and strikes a target and comes to rest. And comes to rest means the final velocity is 0 after penetrating a distance of 10 centimeter in the target. 10 centimeter is the distance travelled by the bullet to the target or inside the target. That is to calculate the retardation caused by the target. We need to find the acceleration because they are saying the retardation it means the answer will come in the negative. Now what we need to find out? Acceleration we need to find out for this question. So if we talk about the various equations, the first is V is equals to u plus at, right? Second is S equals to ut plus half at square. Next is V square is equals to u square plus 2as. If you are having confusion in any of the numericals, just write these three equations simply and check whether which of the things given to you and which you need to find out. After that, choose the one equation, just use it in the numerical and start solving simply. Note one thing mostly, that the unit must be same. Like here it is the centimeter. 1 centimeter is equals to 1 meter equals to 100 centimeter. 100 centimeter it is. It means 1 centimeter equals to 1 by 100 meter. Means if I want to convert the centimeter into meter, I need to divide by 100. It will change into meter. It is 1 by 10 meter. This is the conversion I used here. Now come back here. We need to find the acceleration. In the first question, the value of v is given, u is given, but a is not given. T is also not given. Always we are using that equation in which only one variable is existing. All the other values we are already given with. So first is rejected for here. Next, v is given, u is given, s is given, 2 constant, a we need to find out. This equation we can use. Here also t is not given, s is not given. So third one equation of motion we can use easily in this question. So let's use this equation of motion. This is the equation. The final velocity is 0. Initial velocity is 20 square plus 2 into value of a we need to find out. S is 1 by 10 because we are using the all values in the meter. So use this value here. 1 by 10 it is. Next is 0 is equals to 20 is a square. 400 it is plus 2a by 10. 2a by 10 is equals to minus of 400. A is equals to minus 400. 2 by 10, 10 by 2. So A is equals to minus of 2000 meter per second square. This is the retardation. In the case of retardation, or we can write it like the retardation for the given case is 2000 meter per square. If we are writing simply A is equals to what, then we are denoting or representing it with the negative sign as well. So this is your answer of the given question. Next is numerical number 6. Numerical number 6 is a train is moving with the velocity of this. Means it is already moving with the velocity of this. It is the initial velocity 20 meter per second is brought to rest. Final velocity is it is at rest after applying the brakes in 5 seconds. T is equals to 5 seconds. Calculate the retardation. The value of A will come in negative and we have to find the acceleration. Which formula we will use here? V is equals to u plus at. This is suitable for it. V is 0. U is 20. All the units are same. Acceleration we need to find. Time is the 5 second. 5a is equals to minus of 20. A is equals to minus 20 by 5. So A is equals to minus 4 meter per second square is the retardation or the acceleration for the train with which it is moving. Numerical number 7. This is the most important one also. Seventh numerical. Seventh numerical is a train travels with the speed of 60 km per hour from station A to station B. Let this be the station A and this is the station B. A train is traveling from station A to station B towards this side with the speed 60 km per hour and then comes back from station B to station A with the speed of 80 km per hour from station B to station A. Okay. Firstly, what we need to find out, that is the average speed. Average speed we need to find out. What is the formula for the average speed? It is the total distance divided by total time taken. This is the formula for it. Second thing we need to find is the average velocity. Average velocity is equals to displacement divided by time. Total time taken. Okay. Let's firstly work on the first point, that is the average speed. Let the distance between the station A and station B, it is D. Let the distance is between station A and station B is D. So total distance covered is, total distance we need here in the formula. So the total distance is 2D. And now we need to find the total time also. Total time is, let's say this is taking time t1 and this is taking time t2. So what is the total time? Total time is t1 plus t2. But how to find it? We know that the formula of speed is equals to distance divided by time. The formula of speed is distance divided by time. Here we need to find the time. It means that time is equals to distance divided by speed. The distance covered is, we assumed the distance is d and the total distance is 2d. This we need to find out. So the distance is d and the speed for the t1 for the first part is 60 km per hour. 60 km per hour. So this is the t1, and similarly t2 is equals to distance d covered in with the speed 80 km per hour. It means the total time is equals to t1 plus t2, which is d by 60 plus d by 80. This it is. After taking the LCM, we got this value, which is equals to 7d by 240. Now put this thing in the formula. Which formula? In this one formula. Average speed is equals to total distance divided by total time taken. So average speed we need to find out. This is the question. The question is average speed we need to find out. So average speed, it is equals to total distance is 2d, total time is 7d by 240, which is equals to 2d by 1 into 240 by 7d. D is cancelled out with d. It is 480 divided by 7, which is approximate equals to 68.57 km per hour. So this is the average speed. This is the answer of the average speed and the first part of the question. The second is we need to find the average velocity. The second average velocity is 0 here. Why? Because the displacement is 0. Because train is starting from point A, going to B, coming again from B to A. At the same point it started and at the same it is ending. It means there is no any displacement. The displacement is 0. Thus the average velocity is also 0 in the case. Next numerical number 8 now. It is a train is moving with the velocity of 90 km per hour. Train is moving with the initial velocity is given. 90 km per hour it is given. Brought to stop means it is stopping after applying the brakes to produce the retardation of this. Retardation is given means we need to use the negative sign here. Find the velocity after 10 seconds. Velocity we need to find, and after 10 seconds it is we need to find. This is the first point we need to find. Second is time taken by the train to come to rest. In second case, time we need to find, v is 0. Okay, so for the first one, we know the formula, which is v is equals to u plus 80. This is appropriate for it. So v is equals to u is 90. In the kilometer per hour it is, we want to convert into meter per second. So multiply with 5 by 18 plus value of a is minus of 0.5. Value of t is 10. This is now we need to cut it. 9 2s are 18, 9 10s are 2 5s are 5 5s are 25 plus it is the minus 5, which is 20 meter per second. So the final velocity after 10 seconds is 20 meter per second. After 10 seconds, we need to find out how this come to this. Plus minus minus 0.5 into 10. Point will shift one place. Answer is 5 only. That's why. Now come to the second point. In second case also we can use the same formula. V is equals to u plus 80. V is 0 in this case. We want to take the thing to the rest position. Same, because we need to change the unit. So we are multiplying the 90 given with the 5 by 18. And plus acceleration is minus of 0.5. Time we wanted to find out here, at which time v becomes 0. So 0 is equals to 9 2s 18, 9 10s are again 5s are This is the thing. So 0.5 t is equals to 25, or t is equals to 25 by 0.5. That I can write as t is equals to 250 divided by 5. 5 5 is 25, 0. So t is equals to 50 second is the answer. At time when 50 second will pass out, the v final velocity will be 0. Train will come to the rest position then. Now question number 9. Next is a car travels a distance of 100 meter. The distance traveled is given 100 meter. With the constant acceleration, okay, average velocity is given. Average velocity is given. It is 20 meter per second, and the final velocity acquired by car is this. Final velocity is also given. We need to find out the initial velocity and the acceleration of the car. Okay, what is the formula for this? We can use that simply v is equals to average velocities formula we can use here. Average velocity is what? Average velocity is equals to v plus u by 2. Average velocity is given 20 meter per second. V is 25. U as it is we need to find out. 2 is in the form of division here. We'll go to the multiplication this way. So 40 meter per second is equals to u. This 25 will become as a negative. It means u is equals to 15 meter per second after doing the subtraction of the two values. Second is the acceleration we need to find out. For acceleration we can use the equation of motion like v square is equals to u square plus 2s. Yes, this equation is appropriate. V square is 25 square is equals to u square is just now we find out it, that is 15 plus 2 into a value we need to find. S is given 100 and it is already given in the meter. So 25 is a 625. This will come in the negative form. Minus of 225 is equals to 200a. It is 400 after doing subtraction. Divide by 200 equals to a. So a is equals to 2 meter per second square. This is the value for the acceleration for the given question. Now question number 10. 10th question is when the brakes are applied to a bus, retardation produced is given. Retardation produced is given means the sign of the acceleration we need to take negative, and it is in the centimeter per second square. The bus takes 20 seconds to stop. Time is given 20 seconds. To stop means the final velocity is 0 here. We need to calculate the initial velocity and the distance traveled. Second is the distance traveled during this time. These two things we need to find out. Okay, if we are using the first simple equation, v is equals to u plus at. Here v is 0. U we need to find out. The value of a is in the form of negative and it is in the centimeter. So to convert centimeter into meter, we need to divide by 100 into time is 20. 5 2s are 10, 5 5s are 25. 2 again cut with 2. 0 is equals to u minus 5 and u is equals to 5 meter per second. This is the initial velocity. First part solved. Next is we need to find the distance. As we know, s is equals to ut plus half at square. This one we can use here. As we need to find u is the 5, time is 20 plus half, acceleration is minus 25 divided by 100 in the meter. Time is again 20, its square it is. S is equals to 100 plus minus minus, it is 25 divided by 200 multiply by 400. This will give me 2. So S is equals to 100 minus 25 into 2, it is 50 obviously. So S is equals to 50 meter. This is the value for the distance traveled in this case. Now the 11th one. Next question is, a body moves from rest. From rest means the initial velocity is 0 with the uniform acceleration and travels this in 3 seconds. Distance traveled is given in the question. Time is given 3 seconds. We need to find out the velocity of body at 10 seconds after the start. At t equals to 10 seconds after the start, we need to find out the velocity for it. If we are finding the velocity for the first 9 seconds and we just subtract it, or for first 9 seconds we are finding the value of acceleration, then we can simply find the velocity for it at the 10th second. So we are using the S is equals to ut plus half at square. Everything which is given in the question, we are just putting that all values. Acceleration we will find from here. We are finding acceleration for the first 9 seconds. So we need to use the time also as the 9. Because at the 10th second, we need to give the velocity of the body. So we are using the time as the 9 here. Got it? Next is 270 is equals to, this will become 0 here, 1 by 2 into a. One thing here, which is this one thing no need to do like this. Why? Because time is t equals to 3 seconds is also already given. So we will use a 3 second time here for 270 meters. Okay, so we will use this one time. So it means 270 is equals to 0 into 3 plus 1 by 2. Value of a we need to find out, and this 270 is equals to 0 plus 3 3s are 9 by 2 into a. So a is equals to 270, 9 by 2, 2 by 9. So a is equals to 60 meter per second here. This is the value of acceleration when the distance covered is 270 and the time is 3 seconds. Okay, after that what we need to find? We need to find the velocity of the body. For finding velocity, we are having one another formula, that is v is equals to u plus at. V is equals to what now? We need to find out. U is the initial velocity. Acceleration is 60 in the case. Time is for 10 seconds we need to find out. So V is equals to 600 meter per second. It means this is now our answer. From here you will get it. Acceleration, why we found here? Because we need to use the acceleration for finding the velocity in indirect way. That's why firstly we found the acceleration, and we found the acceleration for the given time period, not for the 10 seconds, because 10 seconds we are using later. So for 3 seconds only we are just finding the acceleration, because for 3 seconds only it is moving uniformly, that's why. Now numerical number 12. Numerical number 12 is a body moving with the constant acceleration travels the distance 3 meter and 8 meter respectively. Okay, we are considering a body here which is traveling the 3 meter distance, then 8 meter distance, in 1 second and 2 second. This is in the 1 second and this in the 2 second respectively. We need to find the initial velocity, u we need to find out, and the acceleration of the body, a we need to find out. So we are using the equation of motion here, s is equals to ut plus half at square. From the case 1, which is case 1, that s is the distance is 3 meter, u is as it is, time is 1 second plus half a as it is, time is again 1 second, so 3 is equals to u plus a by 2. This is the first equation. This is for 1 second time period. Now the case 2 is for 2 second time. S is distance is 8 here. 8 meter is equals to u into t is also 2 plus half a, t is 2 ka square. 8 meter is equals to 2u plus 4a by 2. This is 2. 8 is equals to 2u plus 2a. This is the second equation now. The first equation we are multiplying with 2. After multiplying, we will get 6 is equals to 2u plus a. This is our equation. Now from this one star equation, from star and second, we are eliminating the values of u and a. These are the two equations. After changing signs, these two will get cancelled out. Minus 2 is equals to minus of a. So a is equals to 2 meter per second square. This is the value for acceleration. Put a is equals to 2 meter per second square in equation 1. So 3 is equals to u in this equation. 2 by 2. It will get cut. 3 is equals to u, or u is equals to 3 meter per second is this is the initial velocity of the body. So these are the two different values. Is this clear? Hope this is clear. Then the next is numerical number. See here one thing. After cutting 2 with 2, it is not 0, it is 1. So 3 is equals to u plus 1. This will come and change into the negative. So u is equals to 3 minus 1, which will give us 2. So u is equals to 2 meter per second. Now numerical number 13. 13th is a car travels with a uniform velocity of 25 meter per second. A car is traveling with uniform velocity 25 meter per second. This is given for t is equals to 5 seconds. Next is the brakes are applied, and a car is uniformly retarded and comes to rest in further 10 seconds. Means retardation is used here and the car comes to rest after in further 10 seconds. Means at t equals to 10 seconds the car is at rest. Find the distance which the car travels before the brakes are applied. The velocity is uniform. First is what we need to find the distance traveled before the brakes applied, means for t is equals to 5 seconds. This is the time when the brakes are applied. Second is retardation. We need to find out with the negative sign it is. And the third is distance traveled by car after applying the brakes, means for t is equals to 10 seconds. Again we need to find out the distance. As it is moving with the uniform velocity, so the first distance we will find easily by using the formula speed is equals to distance over time. What is the speed given? It is 25 is equals to distance we need to find out divided by time is 5 seconds. So the distance is 25 into 5 meter. It is 125 meter. Second part, next we have to find out the acceleration. For finding acceleration, we know the formula v is equals to u plus at. The v is 0, u is 25. Acceleration we need to find out, that is in the form of negative will come. Time is we are taking 10 seconds. Why we are taking 10 seconds? Because the body is when started retarding. Means At the 10th second, it starts retarding. It is actually retarding, then it reaches the 10th second. It means we will use the time t equals to 10, because till the 5 seconds the body is actually accelerating or going with the uniform velocity. That's why we are using the 10 second here. So 10a is equals to minus of 25, or a is equals to minus 25 by 10, which is giving a is equals to minus 2.5 meter per second square as the answer for the retardation. Third is again the distance traveled by the car after applying the brakes we need to find. It is s is equals to ut plus half at square. S is equals to u is 25, t is 10 we are taking here. The retardation is this, just we found it, and this u is given already. Time is for 10 seconds, we need to find out the third point, plus half. Acceleration is this, time is again 10 seconds. So s is equals to 250 minus 2.5 by 2 into 100. After solving the calculation, you will get the value of s is equals to 125 meter. This is your answer. Now numerical number 14. The question number 14 is a spacecraft flying in a straight course with a velocity of 75 km per second. This is the initial velocity, it is 75 km per second. Fires its rocket motors for 6 seconds. For t is equals to 6 seconds. At the end of this time, its speed is 120 km per second. Means the final velocity is 120 km per second in the same direction. Find, first is spacecraft's average acceleration. First is average acceleration we need to find out while motors were firing. Second is distance traveled. By the spacecraft for the first 10 seconds after the rocket motors were started. The motors have been in action for the 6 seconds only. We need to find for t equals to 10 seconds, but the motor were in action only for the 6 seconds. This is also given to us. How to solve this question now? Firstly, we need to find the first part, that is the average acceleration. Average acceleration is, we can find as like a is equals to v minus u by t. Like this also we can find average acceleration, or with v is equals to u plus at by this formula also. This is because the advanced version of this only. So with this also we can find, it is 120 in the form of kilometer. It is, put all the values which are given already and do the subtractions here. 120 minus 75 divided by 6 is equals to a. I am doing in short that all things. It will become 45 divided by 6, which is equals to a. Cutting on the table of 2, that is a is equals to 7.5 kilometer per second square. Why kilometer? Because both the units are given in the kilometer only. That's why. And because both the units are in the same, that's why we no need to change the units. Okay. Next is, this is the first part. Average acceleration is done. Now come to the second part. For the second one, what we need to do, we need to find the distance traveled. We need to find the distance traveled for the 10 seconds. But they said that the motor having been in action only for the 6 seconds. So we will find s is equals to ut plus half at square for the first 6 seconds. U is 75. For the 6 seconds, we will find it. And this is also for the 6 seconds, because we find it for the time 6 only. 7.5 into square of 6. S is equals to 450 plus 7.5 by 2 into 36. After solving the cutting of this here, S is equals to 450. After solving these two, we will get 135, which is equals to 585 kilometer. This is the first distance. Now we need to find the distance for the second case also, because this is only for the 6 seconds and we need to find for the 10 seconds. For 10 seconds, for the next one, how much is left now? 4 seconds left only. Means we have done for t is equals to 6 seconds we have done. Total it is 10 seconds. T2 is how much? Total minus T1, which is 10 minus 6. Means for 4 seconds it is left. T2 is 4 seconds. That is left to find out now. Okay, so for this we are using the S is equals to D by T. We know the simple formula. We need to find the distance. So distance is equals to speed multiplied by time. Distance is equals to, again same, or we can say it is S2 is equals to, speed is what? Speed is 120. That is the final speed. The final speed given is the 120. So S2 is equals to, distance is equals to speed for ending multiply by time taken which was left now. S2 is equals to 120 into 4 is 480 kilometer. Okay. After this, we are having the two different distances, but we need to find the total distance. What is the biggest question? The question is the second is the distance traveled by the spacecraft in first 10 seconds after the rocket motors were started. The motors having been in action only for the 6 seconds. So for 10 seconds, we need to find the total distance. It is as total distance is equals to S1 plus S2, which is equals to 585. Yes, it is 585 kilometer plus 480 kilometer, which is equals to 1065 kilometer, and this is your answer. Last numerical of the exercise, it's the 15th one. A train starts from rest and accelerates uniformly at a rate of 2 meters per second square for 10 seconds. Acceleration of the train is given for 10 seconds, that is 2 meters per second square. It maintains the constant speed for 200 seconds. Constant speed is there for 200 seconds. The brakes are then applied to the train for its uniformly retarded and come to rest in the 50 seconds. In 50 seconds, train retarded and comes to the rest. So U is equals to, this is given firstly because the train starts from rest. Acceleration is given 2 meters per second square for time 10 seconds. This maintains the same speed for the 200 seconds. Then the brakes are applied for uniformly retarded motion and it comes to rest in the 50 seconds. But we need to find the maximum velocity reached, the retardation, acceleration means ki for the last 50 seconds, and the total distance covered, S. Average velocity of the train. These are the things we need to find out. The first is maximum velocity. Maximum velocity, how we can find? We can find simply by using V is equals to U plus AT. V is equals to U is 0 plus acceleration is 2 for time 10 seconds. Yes. So V is equals to 20 meter per second. This is the maximum velocity reached by the body. Then the second is retardation. We need to find for the last 50 seconds. For finding retardation, same formula we will use. V is equals to U plus AT. Because in the last 50 seconds, it means the final velocity is 0 in that case. And the initial velocity is something that is we found just. That is the 20. Plus acceleration is what? Acceleration is already, we need to find out the acceleration. Acceleration we need to find out here. Okay. And in the last 50 seconds. So 50 we will put here. A into 50 is equals to minus of 20. Then A is equals to minus 20 by 50. A is equals to minus 2 by 5, which is equals to A is equals to minus of 0.4 meter per second square. This is the retardation. That's why the negative sign. Then the third is the total distance traveled. How we will find the total distance traveled now? This is the very main part. We need to find the distance for the different positions and places. Firstly, for finding the distance, we are using this formula. S is equals to ut plus half at square. Firstly, we are going to find the distance during the acceleration. During the acceleration means for first 10 seconds when the acceleration is there. S is equals to, it started from rest for 10 seconds plus half into this. It is equals to, S is equals to 100 meter. This is known as S1. Let it say S1. Then the next is the distance covered during the constant speed. During the constant speed it was 20 for 20 seconds. Okay, now this was during the acceleration. Distance during the acceleration. Second, S2, I am going to find the distance for constant speed. So S is equals to d by t. Speed is equals to distance over time. Distance is equals to speed multiplied by time. Distance is what? Distance is S2 is equals to speed kitni thi? The speed is 20. This one after 10 seconds. And time is for 200 seconds. It was going smoothly. So S2 is equals to 4000 meter. This is the value for S2. Now see, 10 seconds also done, 200 seconds also done. Brakes are applied for the last 50 seconds now left. During distance during the retardation time we need to find now. Distance during the retardation time is, let's say it is S3 during retardation time. So S3 is equals to again U into T for last 50 seconds plus half into A. This one A we will use here for the last 50 seconds. A we just found out it in the second point, that is the A is equals to for the last 50 seconds. So A is minus of 0.4. S is equals to U T into half into A into T square will come here. 50 is a square. Alright. After that we need to solve this. 5 2s are 10. 00 it is 1000 plus minus minus 0.4 divided by 2. 5 5s are 25. 00 will come here. Then 1000 minus, after doing the calculation here also, 0.4 into 1250, it is 1000 minus 500, which is 500 meters. So S3 is equals to 500 meter. It means the total distance covered is equals to S1 plus S2 plus S3, which is equals to 100, this one, plus 4000 plus 500 in meter. It is 4600 meter is the total distance traveled. Now the fourth and the last point, average velocity of the train. How to find the average velocity of the train? The average velocity is equals to total distance divide by the total time. The total distance is 4600. Total time is 200 seconds. This 50 plus 10 is this 60. It's 260 seconds is the total distance. 10 will cut. After solving it, we will get an approximate value which is equals to 17.69 meter per second inverse. That is the average velocity. So this is the answer for it. Hereas this question has so many parts, so you can explain this answer in two paras, in two just lines at the last also to explain your question very well. Like you can write that the maximum velocity they said to find. Firstly, the maximum velocity is 20 meter per second. Retardation in last 50 seconds is 0.4 meter per second square. Total distance traveled is 4600 meter. Average velocity of the train is 17.69 meter per second. 17.69 meter per second. Like this you can easily explain your complete answer in the two lines just. So with this our exercise questions finished. Now let's take a fast look on the solved numericals also. The first one is a car requires a velocity of 72 km per hour in 10 seconds. The velocity requiring is given, in which time it is given, starting from the rest. V is equals to 0. The initial velocity is u is equals to 0. V is given to us. Time is given to us. We need to calculate the acceleration. Simply V is equals to u plus 80. This formula you can use. This is the advanced of this. These both are same. Any of the one relation you can use here. This is also right. Okay. After putting the values, you will get your answer. Because like here, see, V is given 72. U is the 0. Acceleration you need to find out. Time is 10 seconds. You will get your answer in the kilometer per hour. Kilometer per hour you need to convert into the meter per second here. Note this point. Okay. And the next is the average velocity you need to find out. Average velocity is what? Average velocity is u plus v by 2. U is 0. V is what? V is given already. That is 20. It is actually 72 km per hour, but it is in kilometer per hour. We after converted it into the meter per second, it is 20. So u plus v, both the values divided by 2 is your average velocity. Distance travel in this time is, S we need to find out. S is equals to average velocity multiplied by time. Average velocity is 10. Multiplied by time is also 10 seconds given it is. The last one, distance, you can find by using this formula also. S is equals to ut plus half at square. This is also right. The next one is a ball is initially moving with the velocity. Initial velocity is given u. Final velocity is, its velocity decreases at the rate of, means acceleration is given now. Velocity decreases at the rate, means it stops. V is equals to 0 then. How much time will it take to stop? T is equals to question mark here. And how much distance will the ball travel before it rests? In total that time period, for by using that time we need to find the total distance, means S we need to find out. S we need to find out here. This you can do the calculation part easily. The next question is, a body initially at rest travels a distance of 100 meter in 5 seconds. Distance and time is given with the constant acceleration. First is the acceleration we need to find. Final velocity we need to find. Acceleration and final velocity. Two things we need to find here. Distance is already given. Time is already given. Acceleration we are finding by using this equation, because initially the body was at rest, so it means the u is 0 here. By taking u 0, after solving all this simplification, we will get the value for the acceleration. After getting acceleration, we will use the first equation of motion and get the value for the velocity, final velocity also. This is very easy. Important also. Next, fourth one is, a car initially at rest. Initially at rest means u is equals to 0. Starts moving with the constant acceleration is given. Travels a distance is given. Final velocity we need to find. Time taken we need to find. Both things we can simply very easily find by using the two equations of motion. This you can do easily. Next one is, this question is similar to one of the example. A body moving with the uniform acceleration travels this in the first 6 seconds, this in next. Find the initial velocity and the acceleration of the body. Same similar example we have done also. This is also a very important and easy one. Try to understand by yourself. It is very easy. We have done this kind of example. Next is, a body with an initial velocity of this. Initial velocity is given here. Accelerates uniformly at the rate of this. The acceleration is given in centimeter per second square. See here, both things we need to change. It is in the kilometer per hour. We need to change in the meter per second. This is in the centimeter. This we need to change into meter per second. This is in the kilometer per hour. This also we need to change into the meter per second. Here. Okay. Then distance is given. Acceleration we need to find in the meter per second square. Acceleration is already given. We need to find in the meter per second. Final velocity is already, we need to find out. Initial velocity is given already. So initial velocity converted. Final velocity you will get by using this equation of motion. Seventh is, a particle initially at rest moves with an acceleration is given. For this, find the distance traveled in 4 second, 5 second and the 5th second. This question is also very easy. For the 4 second, firstly we will apply the equation of motion. S equals to ut plus half ut is here. This one equation. And for the 5th second also we will apply the same equation of motion. After finding for the 4 second and 5 second, what you need to do, you need to simply subtract that both for the 5th second, because for first 5 seconds, for the next first 4 seconds, if you will do the subtraction of these two, you will get the distance traveled in the 5th second only. Then the next is, 8th example is, a particle starts to move in the straight line from a point with the velocity this. Starts to move with the velocity. This is the initial velocity. Acceleration is given in the negative, means it is retardation here. Find the position and the velocity of the particle at t equals to 5 second and at t equals to 10 second. At two different seconds we need to find the position, means we need to find the distance of the body, at how much height the body is actually. Okay, so as we need to find out, u is given, time is given, acceleration is given. Put all the things, you will get your answers easily. Hope so. The numericals solved and unsolved both are clear of this 2C exercise of 9th standard. If any of the queries still you are having, you can comment below in the comment section. I will try to surely give the response. We will surely solve your queries. Till then, take care, keep practicing. We'll meet you with the next chapter, any other chapters video. Thanks for watching. Please subscribe to my channel and share with your friends also.